some solving cubic equations questions. One thing that you will notice in the new version of the Maths Method syllabus is that you don't have to factorise cubics, but you do have to be able to factorise quadratic, so we will have a look at some that involve that. So we've got here our first one, it's in factorised form, so we're just using our null factor law to solve that. So we know that either x minus 1 equals 0, or we've got x plus 2 equals 0, or we have x minus 4 equals 0. So that means we know that x must be equal to 1, or x is equal to negative 2, or x is equal to 4. In the next one, slightly different in that we've got a x minus 4 squared. That means that we're only going to get two answers for this because we know that that would be x minus 4, x minus 4, x minus 6. So when we did our null factor law, we would get x minus 4 equals 0, x minus 4 equals 0, or x minus 6 equals 0. So x would equal 4, but it also equal 4 there, and then here it would equal 6. So then we would have x is equal to 4 or 6. So that means we get the same answer when it's that squared one. Then we've got one here where it isn't in factorised form, but we can factorise it because we're not being expected to factorise a cubic, we're just looking for a common factor. So we can say that x outside of x squared minus 2x minus 8 is equal to 0. Now we can factorise this quadratic. So we're looking for something that will multiply to give negative 8, but add to give negative 2. So two numbers that will multiply to give negative 8 but add to give negative 2 are going to be our negative 4 and 2. And so we can put that into our brackets and write x, take away 4, x plus 2. And now we have our factorised form. So we were only expected to factorise in the quadratic form, not a cubic. So we are factorising the cubic but not using our division of polynomials method that we used in the first version of the Maths Method syllabus. So here we're then able to say that x must be equal to 0. I'm going to just do this the quick way and say it must be equal to positive 4 if we've got x minus 4 equals 0, and negative 2. So when you graph that cubic, you'll know that it will cross at 0, 4, and negative 2. Usually when we're solving our cubics, that's what we're doing it for, so that we can graph them. And then we've got here another one where it's not factorized, but what we can do is use grouping methods. So what we can do here is we've got x cubed minus x squared. We can take an x squared out the front and we get x minus 1 there. And then here we've got x minus 1. And I'm just going to put that in brackets so it looks a little bit easier to see how we can then factorize that. So if I put a 1 in front there, we can then take out the factor of x minus 1 out the front. And in the second bracket will be x squared plus 1. So we now have a factorized form of that. So we know that x minus 1 must equal 0, or x squared plus 1 is equal to 0. So here we've got x minus 1 equals 0, so we get x equals 1. Here we would take our 1 to the other side, but then we have x squared equals negative 1, which we can't solve because we can't do the square root of a negative. So here we would just have the one answer of x equals 1 for that equation. Then the next one, we're told to use our calculator. So a couple of ways that we can do that is we have our y equals, and we can put that equation in there and look where it cuts the x-axis because that's what we're solving for, those x-intercepts. So we have x to the power of 3, then we've got minus 19x, oops, hit the wrong button there, x, and then plus 30. So then we're looking where that's equal to 0. So I can see those 3 points there. So I can then just put my trace on and find those values, or I could go to second trace and find my zeros. I just would have to tell you where to look. So if I go between negative 10 and 0, that'll get me this one here, and it tells me that's at negative 5. So I've got a negative 5 there. Then I can see this one over here. If I put my trace on and get near it, I can see what about the x value is. So I'm getting close, it's taking me a little while. So it's about 1.96 or around 2. So if I tell it to look for the 0 between 0 and maybe 2.5 because they do look quite close together. So it's found that 1 at 2 for me. And then the other one looks like it could be, well, it's obviously bigger than 2. So if I go then second trace 0 between 2.5 and 10, that will then find me the other one, which is at 3. So then I've got my 3 values there. If we look at that previous one, I'll show you how we can also do that with that x to the power of 3 minus x squared. Oops. Let me try that again. So x to the power of 3. Then I've got minus x squared. Then I have the plus x, take away 1. And when I graph that, see how we've just got that one spot there where it's cutting the x-axis, and we got that x equals 1. So we can see why we only got the one solution there. And we can also use that same process of using the 0 and going between negative 10 and 10. And it found that 0 for us. So just want to show you with one that wasn't as standard as the one we just looked at on our calculator. Now the last one that I've got here is where we've got 2 outside of x minus 1 to the power of 3 equals 32. So my first step is I'm going to divide both sides by 2. So I get x minus 1 cubed is equal to 16. Then I want to find out what the cube root of 16 is. I want to do the cube root of that. I'm just going to write that there, the cube root. Now, when I'm doing that on my calculator, I can do 16 to the power of, and I make it 1 divided by 3, which should have worked out as a whole number. So, I'm not sure what maybe I have copied that down incorrectly. I'm wondering if this was meant to be a 16. So, it obviously hasn't given me a whole number. So I can keep going with that and just leave it in its third, leave it in that form. So I've got 16 to the power of 1 over 3. It gave me that 2.519. And then I can add the 1 over there. So my x is going to equal that value there plus 1. Or I could put it as the decimal. And then when I graph that, the other option too is that I can take that 32 over and get and solve it for the 0 there and graph it that way. So I can graph my y equals 2 outside of x minus 1 cubed, take away 32. So I can pop that into my calculator and I get 2 outside of x minus 1 to the power of 3, and then I've got take away 32, and then graphing that, and we can see there's our cut there. If we zoom out, we'll probably see where the turn is. Putting our trace on to find that 0 between negative 10 and 10, and we get that 3.5194. So when we worked this one out, it was that 2.514. When we add the 1, we'll get the 3.514. So it does come out as a decimal answer. So 2 ways we can check that. So not an error in the copying down, just gave us a decimal answer, and that's okay to sometimes get the decimal answers. We could try and leave it in third form if we wanted to. Okay.